So we have a very unappreciated and underrated holiday this week. May 4th is Star Wars Day. May the 4th be with you. So I thought we should check in with some of our friends to see what they think about this lesson today.
I have a bad feeling about this. I've got a bad feeling about this.
I have a bad feeling about this.
Very bad feeling about this.
I got a bad feeling about this.
I have a bad feeling about this.
I got a bad feeling about this.
A really bad feeling about this.
I got a bad feeling about this.
I've got a bad feeling about it.
Quiet.
Whoa.
Ouch. Well, that wasn't very confidence inspiring, was it? Well, I still believe in you guys. I think you can do it.
The Emperor does not share your optimistic appraisal of the situation.
Ouch, that was rough again. Well, regardless of what everybody else's opinion has been, I still expect you guys to try on this homework.
Try not. Do. Or do not. There is no try.
Sorry, Yoda. When you're right, you're right. I stand corrected. So I'm expecting you guys to do this homework.
Timar the Math Wizard, have you seen my father?
I am your father.
No, that's not true. That's impossible.
Search your feelings. You know it to be true.
No! Timar the Math Wizard, I love you.
I know. Search your feelings. You know it to be true.
Oh, I'm sorry, I messed it up.
I'm not gonna like react at all.
Am I supposed to react after he says I know? Oh!
You could
Roll your eyes,
You could be
Cliff.
like,
You can just.
Okay.
Algebra 1, we're in 9.7. There's a sheet of notes that accompany this. It's the last section of chapter 9. So most of the rest of the next week or so will just be getting some homework done, getting some reviewing in, some quizzing, some testing, those kind of things. So 9.7, we're talking about inequalities. So we did inequalities a few chapters back. Inequalities just mean that equations, the equal signs, are out, and we have in greater than's, less than's, greater than or equal to, less than or equal to, and then very rarely, but not appearing in today's lesson, but in the old chapter, very rarely, we have not equal to signs. So just to recap what we were doing with that in an old chapter, which doesn't impact today, but just trying to make some connections. For greater than questions, we were graphing pieces of a number line. So if I'd say x was greater than 2, we would do an open dot, because we weren't including the 2. And greater stuff is to the right on the number line. If I did less thans, I would still do an open dot because we're not including the number itself. If I were going to be less than 2, 2 itself doesn't do the job, but we go left on the number line. When I threw the equal to sign on the problem, to be greater or equal to meant we would do a dot like this where we would fill it in to illustrate that that does get counted. If we're greater than 2 or equal to 2, 2 itself would be fine, and anything greater is still headed right. Less than or equal to, we filled in the dot to include it, and then headed left. Not equal to, we didn't fill the dot in, because if I say what part of the number line doesn't equal 2, well, 2 itself doesn't count, but everything to the right and left counts. So you basically get an entire number line with a hole in it. We did that before. None of that impacts today's lesson, other than making that connection maybe helps you understand a little bit what we're about to do. I'll make my way back over here to make a difference, but first I'm going to do a couple other problems this way. So the first thing they're going to ask you to do in the homework, which will be on page 403, they're going to give you on numbers 1, 2, 3, and 4 a handful of problems where they're going to ask you just whether something is a solution or not. To see if something is a solution, you always just try to plug those numbers in. So we've been dealing with ordered pairs all chapter. First number is x, second number is always y. They're just asking us to see if 2, 4 is a solution, to put those numbers in. In place of the y, put a 4. In place of the x, put a 2. And then ask yourself, is this true? Is 4 bigger than 2 plus 3? Well, 2 plus 3 is 5. 4 is not bigger than that. So for something like that, you would say no. If I put in 3 and 8, again, first number goes in for x. So if I take this equation and I replace the x with a 3 and have 3 plus 3 then, and I replace the y with the second number in the order paired with the 8, and ask myself if that's true. 3 plus 3 is 6. 8 is bigger than 6, so that is a yes. Second thing they're going to have you do in the homework, and that actually won't be the next group of problems, it'll be the last group of problems, but it's the next thing I'm going to do now because I think it's easier to understand. They're going to have you graph some inequalities, but we're not going to be doing graphs like these. What we're going to be doing is graphing lines like we have been all chapter. The easiest way to graph a line is to get the equation y equals mx plus b is slope-intercept form. The slope's the number with the x, the intercept is the other number. Graph the intercept, graph the slope, and then you have a line. What's different today is a little bit of this open dot, filled in dot kind of an idea. Sometimes the line itself counts, sometimes the line itself we do not want to count. So here's the way this is going to go. For anything that does not have an equal sign, we're going to do a dotted line. It might be going uphill, it might be going downhill, but anything without an equal sign is going to have dotted lines, which mean don't include the lines themselves as part of our graph, part of our solutions. If the problems do have an equal sign, you're going to go and do some sort of a solid line. It might be going uphill, it might be going downhill, but it's going to be some kind of a solid line going on. Then, if it's greater than, we want to include everything above the line. So I'm going to take a brief walk to my right and grab my colors, because I don't get a lot of opportunity to use my colored chalk in a year, so I don't want to blow one here today. If we want to include everything above the line, I'm just going to shade in everything above the line. When you go to do this homework, you have a couple choices. One would be to get a little bit artistic and use some color and just get everything above the line. Second thing you could do is just make a scribble for those of you that don't feel artistic at all. Anything that's less, we're just going to go under the line. So if you're in more of a scribbling mood, go ahead. Anything that's greater, we're going to go back to above the line. And I'm feeling a little bit more artistic than a scribbler today. Anything with a less than sign, we would color in below the line. If anybody is feeling super artistic, I'll make another walk over here. I have a thing over here that I call the Algebra Art Hall of Fame, where I've had people who have felt extremely artistic, and they have designed little works of art to fill these areas instead of just scribbling in them, or instead of just coloring in with some color. Some people have gotten quite artistic over the years, and I'm not going to go too crazy looking through all of these. Well, I'll show you one or two of some art pieces. So it started off people just doing sort of like some drawings. So I don't know if we can get a zoom in on that.
Yeah.
So this is like a crayon version. Somebody did some Pepsis and Steelers and Penn States and started off with a little bit of color drawings, and that's fine. I've had other years where people went a little more just sort of like random designs, nothing in particular going on there, but artistic nonetheless. Eventually, I had some people that wanted to start to do themes, so there's one in here that's like flags of the world done with crayon and such. And then I had some people decide to go a little bit like mixed media kind of stuff, and they started cutting and pasting pictures instead of drawing their own. And I'm okay with that. I mean, it's still art after all. Let's see if I can, here's a pretty good Garfield. There's a high quality item right there. This person did candy wrappers. So they had candy wrappers, taped in their candy wrappers on one side and Jonas Brothers on the other. Sort of interesting. We had video game cutouts, variety of video game cutout thing on that one, race cars on that one. Well, I'm not going to belabor the point. I think you get the point on that. If you're interested in doing that, the ruling is every single one of the pictures has to be artistic. You can't go like one artistic picture and then think you're going to make it in the Hall of Fame. You have to go artistic on all the coloring pictures. If you have no interest in that, that's fine. If you like artsy kind of projects, you might enjoy that instead of just coloring in something to have like a art masterpiece of some sort. Go for it. At this time of life, especially in coronavirus season, you may have more time on your hands than you usually do anyway to just do artsy kind of projects. But here's where we're headed. You want to have the Y's alone, so if we look through the board, you'll see some of the Y's are alone and some of them are not. This Y is alone, so this is an easier problem. I'm always going to look first to the intercept. With an intercept of 4, I'm going to go up 4 and make my first dot. And then I'll look second to the slope. The slope is always the change in Y on top of the change in X. The change in X for the bottom will always take you right. The top for the slope may take you up if it's a positive problem, but sometimes it'll take you down if it's a negative problem. This is a positive problem, so I'm going to go up 2 squares. I'm going to right 3 squares from where I am located with my first dot. So up 2, right 3, and then I need to play connected dots, but don't just draw a standard line. If you don't see an equal sign, do a dotted line. If you see an equal sign, then do a solid line. I don't see an equal sign, so I'm going to do a dotted line. And then with less thans, I need to get under that line, and I have my choice. Do I feel like scribbling? Do I feel like being a little bit artistic but not making the Hall of Fame? Or do I want to design a masterpiece in this space? But we just need to be below the line. For this one, I would do this first by going up 3. With a negative slope, I'm going to go down, but I always go right. So down 2 and right 5 from here. Down 2, right 5. I see an equals, so I'm going to do a solid line this time. And for graders, I need to get up above. Anything with a greater sign, we go above. Some aboveness. This one's harder because the Y's not alone. If the Y's not alone, you'll need to get the Y alone. So leave the Y stuff there and do an opposite to get the X's out of there. Adding positives, the opposite of that is to subtract the 2x. Then I want to divide by 3. If I divide by 3, I'll get a 3 minus a 2/3 x. And then we're ready to roll. The intercept, the plain old number, always do that first. So up 3, I make my first dot. A negative slope, slope is with the x, negative slope will go down. Down 2 squares and right 3 from where I was already. Down 2, right 3. Didn't have an equal sign, so it's a dotted. And then it's less, so I need to go below. For this one, the Y's not alone. So I have some work to do to get the Y alone. I'll leave all the Y stuff there at first, leave the 8 there at first. Since it's adding a negative, the opposite of that would be to add a positive. So I'm going to add a 2x If I add 2x, it's going from one side. And whatever I do to one side, I'll do to the other. So I'm adding 2x. Then I'm dividing by 4. 8 divided by 4. 2 divided by 4 has to go fraction. 2 divided by 4 is a half x. Always the intercept first. So up 2 to get the intercept done first. The intercept, again, doesn't have an x by it. The slope happens second. That does have the x by it. Top is positive, so go up 1 square. The 2 on the bottom always will send me right 2 squares. I see an equals, so that one is solid. And then with a greater than kind of problem, I want to get above that. For this one, the y is not alone, so I'll have to get the y alone. That's not going to change the xy stuff. To get the add 3 out of there, I'll subtract 3. -5, subtracting 3 more, I'd be down to -8. So I'll graph the intercept first by going down 8. The slope, I don't see a fraction, but I can make one by just putting it over 1. Positive slope goes up 2, and the bottom always takes me right. So up 2, right 1. I see it equals, so I'm going solid. I see a less, so I need to get underneath that. Mix up quite a new color in here. So less goes under. This y again, not alone, so leave the y stuff there, leave the x stuff there. Opposite of add 1 is subtract 1. So if I subtract 1, I get rid of that. Do the same to the other side. 7 subtracting 1 is down to 6. Get the y completely alone. 5 divided by 2, and 6 divided by 2 is 3. Intercept first goes up 3. A slope of 5 halves would be up 5 more from where I was, and always right 2. Dotted line, because I don't have an equal sign, and I didn't remember all my arrowheads, I don't think, so quick step back through here. This stuff should all have arrowheads around. And then I'm going to go above the line. So here's one for you scribblers, just scribble above the line. If you only see one variable, life got easier. You don't have a diagonal line to do, you just have to go one quick location. With a y and 7, this is the y-axis, so I would just go 7, 1, 2, 3, 4, 5, 6, 7, and I'd stay there by making a horizontal line. We've done those before. This would be a dotted line because there's not an equals. And then greater continues to go above. Here's another one for you scribbling fans. If there's an x problem, the x-axis goes that way. So this is just sending me right 2. And then I stay there with a vertical line. Since this has an equals, I'm going to do a solid line. And this is the one exception to my greater goes above and less goes below rule. There is no way for a vertical line to ever get above it because it's going to rise forever. This one case only where you have an x vertical line, greater needs to be the stuff on the right. So this is a greater problem, and I'm going to go to the right. Then the other thing that's, okay, so that part of the lesson will take you from 11 through 31. 11 to 31 will be graphing the way that I graphed. I think that's easier to do than what the 5 through 10 is. What the 5 through 10 is going to do is go backwards. So 5 to 10, they're going to graph you a graph, and they're going to ask you to come up with the inequality for it. So here's just a made-up graph. So I would always go y. I would look at where they've shaded, but I didn't pick a place to shade yet, so I'll shade in a minute. But where the shading happens decides whether it's a greater or a less or an equal to's or what. There's always going to be an x, and there's probably going to be another number. So I would look first for that other number. Like when I graph this, I graph the 3 first. If I find the y-axis touch, the y-intercept. What I would do on this is look for the y-axis touch. From the origin, that's up 3. So this problem is going to have a plus 3. Then I would try to find any 2 points, and my points on the board I've made more obvious than the points are, I think, on your homework page. They haven't done like these big dots. But look for places where the line is touching corners of the squares on the graph paper. And so if we look at these 2, you can see that I moved up 1 and over 3. From here, I moved up 1 and over 3. This line will forever move up 1 and over 3. That means it has a slope of 1/3. If, let's say, I had shaded it like this, that would be a greater than sign. It's greater because I just went above, and since it was a dotted line, I did not put the equal sign on it. If this were a solid line, I would do the equal sign. Or if I had shaded underneath, I would have done a less than sign. So always a y first, always an x next, and then just kind of look at the picture. I would look first for a touch point that's on the y-axis and count how far up it is from the origin. 1, 2, 3, 4, 5 squares. So that means there's a plus 5 for the intercept. Then I would try to find some squares where I clip the corners of squares. So here's one, here's one, here's one. From here to here, I move down 3, right 4. Down 3, right 4. This graph keeps going. Down 3, right 4. Down 3, right 4 to clip corners. So that means it has a slope of -3/4. If I'm in the mood to shade in underneath, then I would do a less than sign. And I would not include the equals because that was just a dotted line. Dotted lines don't have the equals. Scrolling to the right again. Always start with y and you'll always need an x. The only way you wouldn't need an x, 1 out of 100 times, if you had one of the lines that went like this, that only has a y. If you had a line that went like this, it would only have the x. But 99% of the time, it's a diagonal line, you need both of them. So again, look for the touch point first. It's up 3, so I'm going to do a plus 3. Then I clipped corners of squares here and here as well. And I rose up 1, right 2, up 1, right 2. The pattern for the slope is a half because it keeps going up 1, right 2. If my shading had been there, I'd have done a less than. But since the line's a solid line, I'm going to make it an equal sign as well. So this one I might as well go above it. So that would be a greater than equal sign. Greater because I'm above, equal because it's solid. Find the y-intercept first. 1, 2, 3, 4. So a plus 4 at the end. And then look for the spots where this line is clipping corners. There's a spot. There's a spot. And then just count. It's down 2 and right 3. Down 2, right 3. It's a negative slope because it's going down, and you think downhill is a negative slope. And the fraction would be 2/3. And that does it for our homework. So the next few days, we have this homework page to do. The review sheet is coming for sections 5, 6, 7. Quiz on that. Another review for the whole chapter, a test on that. There won't be anything new video-wise for a while. So if you have any questions, things you don't understand from chapter 9, please email me and I'll work it out with you. See ya.